So hello students, today we are going to learn about volume of a cylinder and a cone, which comes under the chapter surface area and volumes. So this is a cylinder, and in the last class we derived that the formula of a cube, and in that we saw that if we stack up rectangles one above the other which are of same size, then we get a cube. In similar way, here there is a circle. This is the bangle which is in the shape of a circle, and if we stack up these bangles one above the other, then it will give us the cylinder. So area of the circle is pi r square, which you have to remember. Derive this formula. So I have stacked up the circles one above the other and we got this cylinder. Now which component increases? So it is the height. So same like the last one, we have to multiply the area of the base circle, in this case, into the height. Therefore volume of area of base circle into height. So area of base circle is pi r square, as area of circle is pi r square, and height. So the formula of volume of cylinder becomes pi r square h, where r is radius of the base circle, height of the cylinder is h. Now we will move on to the problems. Let's read the problem carefully first. The pillars of a temple are cylindrically shaped as shown in figure. If each pillar has a circular base of radius 20 cm, so radius is given, and height 10 meter, how much concrete mixture would be required to build 14 such pillars? So this is a rough figure. So we know that radius is 20 cm, height is 10 meter. Now 10 meter is equal to 1000 centimeter. Here I have written first the statement: since the concrete mixture that is to be used to build up the pillars is going to occupy the entire space of the pillar, what we need to find here is the volume of cylinders. So the whole cylinder will be filled up with the concrete. Now we have the radius, we have the height, here is the formula, and now we are just substituting it. As we all know, pi value is 22 by 7, r is 20. Since it is a r square, it is 20 into 20 and multiplied by the height of the cylindrical pillar. It gave us this value. Now, since one meter cube is equal to 1 crore centimeter cube, we have got this answer by the conversion from centimeter to meter. Now we have to calculate the area of 14 pillars, because 14 pillars are required to be built. Now the volume of each cylinder means each pillar into 14. We got this answer, which is 17.6 meter cube. Now 14 pillars would need 17.6 meter cube of concrete mixture. This is the answer, and we have to state it at the end. Now we will move on to the next question. Let's read this up carefully. Listen carefully. At Ramzan Mela, a stall keeper in one of the food stall has a large cylindrical vessel of base radius 15 cm filled up to a height of 32 cm with orange juice. The juice is filled in a small cylindrical glasses of radius 3 cm up to a height of 8 cm as shown in the figure and sold for rupees 15 each. How much money does the stall keeper receive by selling the juice completely? So first, we are required to find the volume of a large cylindrical vessel. So we are given with the units of radius and height, and both in centimeters. So there is nothing to convert. So first we have to write them. Then The second step is the juice is filled in a small cylindrical glasses of radius 3 cm. So we have to calculate the volume of this small glasses after calculating the volume of the bigger vessel. From that we will get how many small glasses will be filled with that orange juice, or how maximum number of glasses that we can fill with the orange juice in the big vessel through the orange juice from the big vessel. From that we will get how many glasses he can sell, and that will multiplied by the 15 rupees which we are given. Each glass is sold for 15 rupees, and from that we can get the profit or how much money he got. So volume of cylindrical vessel is pi r square h. Then we substitute the values. Let's keep pi as it is since it is not required to simplify it or solve it. The volume of juice in each glass can hold pi r square h, which is in this case the r, small r is radius of that small glass as compared to the capital R, which we have R and H we have denoted for the larger vessel. Now we got this value. Now since we have to calculate the number of glasses of juices that are sold, we will divide the volume of the vessel by volume of each glass. From that we will get how many glasses can be filled. So 100 glasses, we got the answer. Now the amount received by the stall keeper will be 15 into 100 since each glass is sold for 15 rupees, which gives us the answer of 1500. So this part is over. Now we will see the volume of a right circular cone. Now what is right circular cone? So here is a cone. Its vertex and the point on the circumference, if we draw line from vertex center and from center to point on the point on the circumference, we will get a right angle, and that is right circular cone. Now here is one activity, you have to observe this carefully. So in this activity I will show you relation between cylinder and cone. You have to observe how many cones are filled and poured in the cylinder to fill the cylinder up to its brim. From that you will get the relation. So this is a rava or suji. We pour this suji in cone totally, and then we pour this totally filled cone in a cylinder. So this is one. Now we'll fill it with second time. It's totally filled. Now we'll pour it in the cylinder second time, and now it's time for the third one. How many amount of suji in a cone were poured to fill that cylinder? 3, right? So this gives us the relation that 3 times the cone gives you 1 times the cylinder. Here is the conclusion. So 3 times the volume of cone is volume of cylinder if we have height and radius same. So volume of cone is 1/3 the volume of cylinder. Now volume of cylinder, we have the formula pi r square h. We substituted that V of cone is equal to, where V is volume, 1/3 into pi r square h, where r is radius of the base circle, h is height of the cone. Now we'll see the relation between height, slant height and radius. So here you can observe that in the cylinder we can directly measure the height from top end to bottom end, but that's not the case in the cone. In that there is there is one line which is denoted by n l, and that is slant height, and it is always more than the direct height, which is denoted by small h. And the relation between the both of those heights are given as L square is equal to R square plus H square. Now why this formula, how this formula comes, that I will explain you. So we have used Pythagoras theorem in this. So L is the slant height, then which is the hypotenuse, then vertex and center of the circle, base circle, is one side, and second side is the radius from center point to the point on the circumference. And by Pythagoras theorem we get L square is equal to R square plus H square. Now we simplify it and we get this formula: H is equal to root L square minus R square, where L is slant height, R is radius, and H is height. Now we will move on to the problems for the cone. The height of and the slant height of the cone are given, and we have to find the volume of the cone. So we can directly use this formula, we can substitute it, and we get the answer. So we got the radius, and in this way we can find if only the slant height and the real height is given here, and we have to find the radius. So in by substituting the values we found this. But if you are given radius and height and you have to find the slant height, then also you can use the same formula, and same goes for the slant height and radius. You can find the height of the cone. Now we have to find the volume of the cone. Since we have got the radius, we can substitute that radius in this and we can find the answer. And answer is 7546 centimeter cube. Here comes the next problem. Monica has a pipe of canvas whose area is 551 meters square. She uses it to have a conical tent made with a base radius of 7 meter. Assuming that all the stitching margins and wastage incurred while cutting amounts to approximately 1 meter square. So this is the waste out of the total canvas. Find the volume of the tent that can be made with it. So all the values are in meters. So let's keep it in meters. Since the area of the canvas is equal to 551 meters square and area of the canvas lost in the wastage is 1 meter square, therefore the area of the canvas available for making tent is 550 meters square. Now this got us to the surface area of the tent. Now required base radius of the conical tent, which is given 7 meter. Note that the tent has only a curved surface area. Since we don't require the base part, because tent has to be made only on the only the curved surface area is required and not the area of the base circle. So we substitute the values in curved surface area of the cone is equal to pi r l. So we got 550 meters square. we got this relation. We used that relation and we found out the height, because we had the slant height, we didn't had the real height. So we calculated the height and then substituted that height in the volume of the conical tent. Thank you, students.